In this video, I'll be showing how to use the cosine rule to prove a number of trigonometric identities. In order to understand these proofs, we are going to need to understand what the cosine rule states. The cosine rule states that in any triangle ABC, a squared equals b squared plus c squared minus 2bc cos A, or if all I need is lowercase b, b squared can be written as a squared plus c squared minus 2ac cos b, and of course c squared equals a squared plus b squared minus 2ab, the cosine of c. This is the cosine rule for any triangle A, B, and C. And of course, we know that the uppercase letters are the angles and the lowercase letters are the sides facing the respective angles. And of course, we can make, so I'm just going to make this equation 1, equation 2, and equation 3. From equation 1, I can make cos A the subject, and that's going to fetch me cos A equals b squared plus c squared minus a squared over 2bc. So all I've just done here is to move 2bc cos A to the other side. It becomes a plus. Then move a squared to the right. Then divide both sides by 2bc. That's going to get me this. Similarly, b. So I'm going to be relying on all of these to solve the problems in the examples. So let's focus on the first example. The first example states that we should show that b cos c plus c cos b is equal to a. Of course, this is an equality. We had shown that the left side is equal to the right side. So to show this proof, solution or proof, whatever, I'm going to focus on the left and work my way around, obtaining what I have on the right side. Now we've got a b cos c, and I know what cos c is from the cosine rule. So b cos c can be written as b times cos c, that's a squared plus b squared minus c squared over 2ab. Then I've got a plus sign right here, then lowercase c. Now cos b, that's the yellow one, we can see that it's equal to a squared plus c squared minus b squared over 2ac. Now looking at this, b can just cancel b because it's a product, and here c can cancel c. So we can see that the left hand side fetches us a squared plus b squared minus c squared over 2a plus a squared plus c squared minus b squared over 2a. These are fractions with the same denominators. So since I've got a plus between them, so this is just 2a. I'm just going to add the numerators. So that gives a squared plus b squared minus c squared, then plus a squared plus c squared minus b squared. And looking at this is going to be equal to a squared plus a squared. That's 2a squared. B squared minus b squared, that's gone. Negative c squared plus c squared, that's also gone. So I've got over 2a. Of course, 2 can reduce 2. And the a here can cancel one of the a's at the top. So this reduces to a. And looking at the question, we can see that this is exactly what the right hand side is. So we've been able to show that b cos c plus c cos b is equal to a. Let's take the second one. We are to show that cos a over a plus cos b over b plus cos c over c equals a squared plus b squared plus c squared over 2abc. We're going to be relying on those formulas from the previous slide. Now focusing on the left side, so this is the proof. Let's call it a solution. Focusing on the left side, and that's, we know what cos A, cos B, and cos C are from the previous slide. Cos A, for example, is b squared plus c squared minus a squared over 2bc. So in place of cos A, I'm just going to write b squared plus c squared minus a squared over 2bc. Of course, this is going to be 1 over a, because cos A over a can be written as 1 over a times cos A. Now, similarly, cos B, of course, cos B is a squared plus c squared minus b squared over 2ac, and I've got a division by b, and that's 1 over b right here. And also, this is 1 over c. Then cos c, of course, cos c is a squared plus b squared minus c squared over 2ab. Now, this is going to simplify to, of course, this is just b squared plus c squared minus a squared over, now a times 2bc is just 2abc. The middle one here, that's just a squared plus c squared minus b squared. The b is also going to multiply 2ac. That's going to give 2abc. And the final part, 1 times the numerator here, is just a squared plus b squared minus c squared over c times 2ab, that's 2abc. So here we've got addition of fractions with the same denominators. The LCM is just 2abc, and what I'm going to do here is just to add the numerators. So the first part, this is b squared plus c squared minus a squared. The second part, so we've got a plus a squared plus c squared minus b squared, then plus the third part, that's a squared plus b squared minus c squared. Now, we've got a b squared here. B squared minus b squared, that's gone. There's a third b squared, so we are left with a b squared. Now, c squared plus c squared, that's 2c squared minus c squared, that's just plus c squared. Now, minus a squared plus a squared, that's cancelled. We are left with a single a squared, so this is plus a squared over the denominator, that's 2abc. Now, this is what the left side reduces to, and comparing with the question, we can all see that this is exactly the same as the right side, and that completes the proof. Thank you for watching this video. If you find it useful, kindly like it by giving it a thumbs up, share to your friends and colleagues on social media. Don't forget to drop a comment and click on the subscribed icon. To get notified when I upload new videos, kindly click on the all, that's the dark bell button on the subscribed icon. Thank you for seeing it once again. See you in the next video.